Hello, my name is Dennis Hancock. I get to be the Center Director of the U.S. Dairy Forage Research Center, and today I would like to share with you a celebration of 40 years of our research center and the research that we've been able to conduct here and the impact that we've had over the years. I want to begin at the beginning. I want to tell you a little story about the late 1970s as modern dairy farming was coming together as we now know it. There was a period of major transition, and there was a major need for research on more modern, quote unquote, modern forage production and dairy nutrition practices. And so there was a real groundswell of support for that, and Congress actually directed USDA to report on those research needs. So they formulated the National and Regional Dairy Forage Research Task Force that reported back to Congress on needs and desires for additional research that would help in that transitional period. So in 1975, the National Dairy Forage Task Force recommended the establishment of a research center in the North Central U.S. The North Central Experiment Station directors also met in that time period in late 1975 and unanimously voted their support for such a center to be created. So you have a gathering of many states here coming together to really support the idea of a regional approach, or maybe even national approach, to dairy forage research. And this grew even more to include other regions of the country as the planning process began and got further along. So Congress authorized plans for the North Central Dairy Forage Research Center in the fiscal year of 1978, providing $1.1 million for the planning purposes of that dairy research center. And this North Central Dairy Forage Research Center's planning committee planned to have cluster locations associated with ag experiment stations in the upper Midwest and Northeast U.S. This included places like University Park, Columbia, Worcester, Ames, East Lansing, St. Paul, and Ithaca. So largely in the upper Midwest and the Northeast. So planning begins with the development of an interim director. And so we have an assistant director of the experiment station at that time, Harlow Hodgson, who worked for many years with USDA as a forage researcher in Georgia and later in Alaska, and then was an administrator with USDA for 10 or more years after that, and then retired from the USDA and came back to his home state of Wisconsin and served the then director of the experiment station as an assistant. And Harlow was really the first one to begin that planning process, including the facilities, etc. So real credit to Harlow in that whole process as that got underway. Flatt and Associates are the architects for the building and for the farm facilities. But I think really it's worth noting Senator Bill Proxmire's role in this whole process too. He was very much the champion of this idea of the North Central Dairy Forage Research Center. In fact, the transcripts of the committee meetings in 1979 read very much like our current mission statements. There's a lot of similarities even today of some of the goals from back then that we still are working on today, and various evolutions of what we were doing back 40 years ago. So the building process actually began in 1979. In fiscal year 1979, Congress approved $9 million for the development of the field facility at Prairie du Sac, which was across from the Bad Year Army Ammunition Project land, and we'll talk a little bit about that in just a moment. But it also allowed for a campus facility, a laboratory facility, to be built on the UW-Madison campus. The original staffing plan was to include the director as well as a number of scientists, and both in Madison and at cluster locations, and to add progressively to that each year we would add scientists both here in Madison as well as in some of the cluster locations that I referred to earlier. Then in 1979, in January of 1979, there was a decision made to call it the U.S. Dairy Forage Research Center. The actual rationale for that has been lost to time, I guess, because it's really not clear why that decision was made. But it really did reflect the fact that this was kind of more of a national effort than just the north central region. It included, after all, northeast locations as well. So I wanted to give you a picture of the overall directorship that has occurred over the years, including Harlow Hodson, who's the one there in the middle in the gray suit jacket. He was the first interim director, and he was closely followed then by Ray Beulah in 1979. And Ray's really the one who kicked this whole thing off with the building of the facilities. Harlow's role was certainly very crucial, but Ray was the one that really carried through the building of the facilities and staffing the center. Then that was followed by Charles Kitty in 1984 through 1986. Dr. Larry Satter, who was a longtime dairy scientist and professor at UW, became the center director in 87 through 98. And then Neil Martin came from the University of Minnesota to serve as the director in 1999 all the way to 2013. He has the distinction of the longest tenure there. And then closely followed by Mark Bogus from 2014 and 2018. He was my immediate predecessor. I came in 2020, January of 2020. So back to 1979, the construction project began. The facilities out at the farm began in 1979 in August, whereas on campus here, construction began in October of 1979. So the center was born, and in 1980, the summer of 1980, the first animals arrived at the farm. They were recipient cows who ended up providing us some calves that were ET calves that were brought in and implanted into those recipient cows. And the field facilities were completed in August of 1980 and dedicated in September of 1980. The next year is when the campus facilities came on board, and I'll speak to that more in a moment, but I wanted to highlight the history here in conjunction with the Badger Army ammunition plant, or simply just the Badger. The Badger lands were to the northwest of the current site of the research dairy, and the areas that are shaded in green there were largely the farmland that were used to support the research dairy itself. But it's important to note that the Badger facility there was the place where the U.S. Army developed it actually in the World War II, and it was active all the way until the late 1970s, producing smokeless gunpowder, nitrocellulose-based propellants, and large munitions for the U.S. Army. It was placed in standby status in 1977, but it wasn't declared excess until 1997. And during that, the whole history of the USDA Forage Research Center, we have harvested forage off of that area that's located there in green. But it wasn't really granted to us in ownership until about 2,000 acres worth in 2004, with some additions in 2005 and in 2014. So those now are owned by the center and operated, and we also lease additional lands from Bluffview Sanitary District, as well as Wisconsin DNR, which owns some of the land that you see in white there. We also have neighbors to the north with the Ho-Chunk Nation, who has returned much of that landscape back to the soft prairie, which it was originally. Of course, much has changed, but they have done a great job of creating a wonderful example of what that soft prairie would have looked like. Here on campus, the lab facilities and office buildings that we have here, that was constructed in 1981 and completed in 1981 anyway, dedicated in June of 1981. And then the process began of staffing the facility with scientists and support staff. And here's a picture from some of the early days there, and the names that are on this list are really just the who's who of scientists working in this area. There's really a great cadre of colleagues here from multiple disciplines that really were off to the races, doing some great research. And we still added on to that beyond just the beginning of that early days of the facility. There was an addition in 2004 of the Environmentally Integrated Dairy Management Research Unit in Marshfield. That research unit was formed officially in 2004, and the building opened in May of 2008. Actually, UW also expanded and rededicated the North Farm in collaboration with us in 2012. And a great heifer research facility located there. A lot of great opportunities for doing grazing work there, and a lot of environmental research conducted there. And I'll talk about some of the highlights of both of those in just a moment. But I really want to emphasize here the necessity of integrated research. One of the real strengths of this facility is the fact that we have multiple disciplines all working together to a common goal here. We weren't siloed into our own disciplines. There's a real integration of those disciplines, just like it is on a normal dairy farm. All of those things come into play when we operate a dairy farm, and so do they instruct our research that we do here as well. So here we have the Dairy Forage Research Unit in Madison, as well as the Cell Wall Biology and Utilization Research Unit. Both of those research units are located here in Madison. And then in Marshfield, we have the Environmentally Integrated Dairy Management Research Unit, which really focuses a little bit more on the environment. But again, there's some natural synergisms, as you'll see in just a moment, how these all come together to help us solve real-world problems for dairy producers across the country. One of the first and probably one of the more well-known accomplishments of this Dairy Forage Research Center is the understanding that came about of forage digestibility. And they, along with many contemporary researchers at the time, developed a very extensive knowledge of the structural and non-structural carbohydrates in plants. This includes things like fiber and lignin and pectins and starches and sugars, etc. This is very crucial to understanding the energy dynamics there, and particularly the kinetics, the digestion kinetics, the rate at which those things are digested in the rumen were studied in this era. The research into manipulating that lignin biosynthesis and the regulation of those processes actually led to the development of reduced lignin alfalfa. That was really an innovation brought about by the Consortium for Alfalfa Improvement, which is a consortium that brought together forage industry partners with research institutes like our research center here at the Dairy Forage Research Center and the Noble Research Institute, and our sister unit at St. Paul, the Plant Science Research Unit, which was originally one of the cluster locations of the Dairy Forage Research Center. And this consortium actually ultimately derived and developed what became known as the reduced lignin alfalfa that's on the market nowadays. So in addition to this reduced lignin alfalfa, the side effects of that, or the co-products, if you will, of that, was some examination of further understanding of cell wall structure and digestibility. A reference book was written from that, an understanding of sugars and carbohydrates and how those are utilized by the ruminant animal. Chapters written in various reference books like this one on dietary sugars came from a lot of research. And much of that continues on today. Similarly, understanding protein digestibility was something that was key to the early days of the Dairy Forage Research Center. Understanding how protein degraded in the rumen, but also in the silage, and understanding how the ensiling process influenced protein degradation as well. So this led to a better understanding of peptide absorption and microbial protein digestion, better understanding of things, for example, of methionine supplementation and how crucial that is to dairy diets and dairy productivity. This led to numerous papers, publications that ended up being written into and informing the NRC's nutrient requirements for dairy cattle. This was the 1989 version. I'll talk about some later versions later on, but it's an iterative process, of course, and they were very influential in setting some of those nutrient requirements, even from this 6th edition. And other reference books like this, Quantitative Aspects of Ruminant Digestion and Metabolism. Very much a key player in writing chapters for those reference materials. During this age, we also developed a better understanding and assessment of the methods for determining forage quality. So our researchers were very instrumental in refining analytical techniques and metrics for measuring forage digestibility and forage quality writ large. They also worked closely with members of the near-infrared spectroscopy community to birth what became the NRS Forage and Feed Testing Consortium that really worked to refine forage testing to include very cost-effective techniques like using NIR. Where things might take a week or longer in the lab to do the benchtop style chemistry that ends up being done to validate all of this and to develop calibration curves, they can accomplish the same thing by measuring near-infrared light reflectance off of a sample in a fraction of the time, in hours rather than days or weeks. So a really cost-effective strategy for forage testing, which was very needed in the industry. This resulted in a publication largely we had a lot of contributors that supplied chapters for this publication, this book called Forage Quality, Evaluation, and Utilization. In addition, the NIRS consortium actually was housed initially within the Dairy Forage Research Center, and we very much supported that development and furthering the work of and accreditation of National Forage Testing Association, actually helping them derive some statistics so they could compare the accuracy of labs to make sure that they were very precise in their measurements and accurate with their measurements, so that one lab would be as similar to another as possible. It's really important for you to select forage labs for analysis that are part of that calibration process and accredited by the National Forage Testing Association. Also, a lot of work that was done on improving silage making. Everything from silage filling, packing techniques, covering, feed out, all of those topics were addressed in various trials over the years, not only at the Dairy Forage Research Center, but certainly we played a major role in that process. And here's an example of some improvements that were made over time. These are the expected dry matter losses for these different styles of different types of silos compared to what a typical range that one might observe in some of the early days of the literature might have been many-fold what those dry matter losses were once they were able to develop good best management practices on that. They also looked at and defined the parameters in which you should apply an effective microbial inoculant on corn, BMR corn, alfalfa silage. They really did a good job of defining when those are going to be most profitable and useful on a dairy farm for protecting those silages. Also creating a better understanding of ensiling time on starch and protein digestibility in that silage and in high moisture corn. So there's some real advances that have been made there. And in fact, there was a reference book here, Silage Science and Technology, that was edited and put together by members of our center along with many other colleagues across the country. And for example, chapters written in this corn silage production management and feeding handbook, also written by our scientists over the years. We've also had researchers working on things like hay heating and trying to work out the mechanisms by which hay heating occurs and how heat damage affects the energy level of that forage and the protein digestibility in that hay, as well as looking at ways to potentially mitigate that, such as with hay preservatives and looking at injecting organic acids onto the hay to preserve that, to prevent hay heating from occurring. And some great work over the years done on that. And things like that end up getting published in books like these, which this 2-volume set on forages, The Science of Grassland Agriculture, that's now in the 7th edition, features many, many chapters written there by various members of the Dairy Forage Research Center, including multiple editions here of this. The 7th editions of each of these 2 volumes have recently come out, and many of our scientists are heavily engaged in writing various aspects of that. Volume 1 is the textbook commonly used as a textbook in the forages courses that are offered across the country at various universities. Volume 2 is a much more in-depth reference book that graduate students and those working in the discipline might have on their shelf as well. So great reference material there. Forage breeding developments that occurred here at the center are also noteworthy. It developed a number of new varieties of clover, bird's foot trefoil, meadow fescue, orchard grass, native warm season grasses, and other forage species that were bred for greater productivity, whether that be yield, quality, persistence, whatever it might be. They also, during that process, developed new breeding techniques and genetic evaluation tools to increase the rate of genetic gains in new varieties. Working with collaborators all across the country, developing new techniques and strategies, and contributing many of the chapters in these books that you see listed here from a wide and variety subject of all types of forage grasses and legumes, such as clover, alfalfa, and trefoil, and looking how these fit within the context of dairy production, as well as writing the book on how to breed forage crops and statistical methods of how to analyze that data. So great amount of research and reference materials coming out of that. Things that really set the stage for further development down the road. Meanwhile, they were also looking at, especially about 10 to 15 years ago, looking at the potential of a vast number of forage species for biomass to biofuel. Particularly the native warm season grasses were evaluated. Things such as switchgrass were evaluated extensively, eastern gamagrass, and many others. And a number of books came out of that effort, including many chapters that were written by scientists from the Dairy Forage Research Center, great contributors to that national effort. Similarly, we've been looking at aspects of the environment and trying to reduce the footprint of dairy production on our environment, especially things like carbon footprint, for example, including a better understanding of how methane, nitrous oxide, carbon dioxide, and other greenhouse gases are influenced by the diet and management practice. So for example, if you drive through our research facility at Prairie du Sac, you might see a tower like this one. It's not a radio tower or a cell phone tower or anything. That's actually an eddy covariance tower. And on top of that, there is a cadre of sensors looking at measuring methane and wind speed and carbon dioxide, as well as the photosynthetically active radiation that's actually measuring how much light is capable of supporting photosynthesis. So in addition to that work, monitoring what's going on in the field, we're also evaluating changes in rations and ingredients and ratios in that ration, and all in an attempt to reduce methanogenesis. And there have been some great strides in reducing methanogenesis in the last several years. In fact, the recent study is showing a remarkable decrease in methane production in the dairy industry just in the last 10 years. So some really good news and something to be proud of, the advances that we are making there. We've also been working hard at trying to minimize nutrient loss. And for example, things like understanding nitrogen excretion rates and the transformations that nitrogen undergoes, the the types of losses and the amount of those losses, trying to put an economic value to that and determining the environmental fate of those losses, not only for nitrogen, but also for phosphorus, for nutrient runoff that occurs in the phosphorus that might be in that. So that's been a really concerted effort among many of our scientists at the center and trying to reduce that. And that's been reduced in a number of different ways, some of which management in the field, but also management of things like in the diet. So they've developed recommendations for ration ingredient ratios that reduce the nutritional need for nitrogen and phosphorus, and thereby nitrogen and phosphorus loading in the environment. So for example, researchers were crucial in writing the ruminant nitrogen usage bulletin for NRC that really refined our understanding of protein and the recommendations of that, especially in regards to rumen degradable and undegradable proteins. And it reduced the recommended protein in the diet by 10 to 15%. And that had a result of reducing the nitrogen excretion by 20 to 30%. So it's a major impact as a result of that. Similarly, on phosphorus, in the 2001 edition of the NRC nutrient requirements for dairy cattle, they had a change that was recommended on the basis of research here at the center, where they found that a reduction in dietary P from 0.45 to 0.49% of the dry matter basis down to 0.38% was able to sustain the same level of milk production, same reproductive efficiency in the animals, no negative side effects of that, except for it reduced the phosphorus in the manure by 20%. So a huge improvement there as well. Additionally, once it gets to the field, finding and comparing different ways of applying dairy manure out in the field, balancing costs and the economic loss of those nutrients, as well as, of course, minimizing the impact on the environment. Crucial part of that too. So that resulted in chapters written in books like Phosphorus, Agriculture and the Environment, a really quintessential book referencing the phosphorus fate in the agricultural industry, environmental chemistry of animal manure, and many other chapters and publications that came out of such work. We've also invested heavily in cover crops and looking for ways of capturing more nutrients on the dairy platform as well, whether that be comparing different species or different mixtures of species, such as in this picture, or looking at living mulch type systems. For example, this is some work by one of our forage agronomists looking at interseeding alfalfa into corn. And so this has multiple benefits to the system. Gives one a jump start on the alfalfa for the next season, and also can benefit the corn to some degree as well, with management and good timing of plant growth regulators, etc. There's some real economic advantage of doing this, and some great recent research published on that subject just this year. Also, a concerted effort looking at contaminants as a result of not only from the dairy industry, but also the rural economy as well. So if you look at groundwater systems, our scientists have been looking at and tracing contaminants in those rural and municipal well systems, looking at things like bacteria and viruses and other pathogens, nitrates, and other contaminants that might be in that well water. So for example, here's just a screenshot of a map of some of the trials where they've been looking at this and monitoring what's going on, looking at some of the impacts of the physiographic region and some of the other factors in the soil and the application strategies, etc., that influence those results. They've also differentiated between human and bovine sources, so they can often detect what is the source of that. Is it coming from human sources, or is it coming from bovine sources like the dairy industry? I thought I would share with you what has happened over time with our research publications from the Dairy Forage Research Center. And if you recall, this data goes back to 1995, when the center was about 15 years old at this point. And what you really see here, I think, is in that when the center became about 20 to 30 years old, you see a maturation going on here. A maturation meaning some of those longtime scientists began to really write a lot of book chapters and books, and you see a growth in the number of other articles beyond just journal articles, referee journal articles. In general, our journal articles have pretty well sustained, very similar, or maybe even grown some over the years. But it's, you see a real influence of that first wave of scientists really writing a lot in summary of their research in the latter stages of their careers. In addition to those reference materials and textbooks that I talked about earlier that we use in classes, there are a number of other reference materials of which our scientists have contributed to over the years. Everything from animal agriculture and encyclopedia of animal sciences to veterinarian clinic guidelines, talking about cell wall development, biosynthesis, structure and function, a wide variety of subject material which they as scientists have contributed to the greater knowledge of life sciences and polyphenols and transformational technologies like the agrobacterium protocols for transgenics. And looking at broader trends too, looking at yield gains over time for our major U.S. forage field crops, as well as the impact of grasslands on our ecosystems. A number of these trials and books have come from research trials that have occurred here at the center and otherwise may not have been possible without this integrated approach among multiple disciplines. And that really is the necessity of that integrated research, but also the benefits of an integrated research model like this. But we're not done yet, and we are going to renew our efforts. In the past several years, my predecessor hired 6 new scientists, but we are in the process also of hiring 6 more. We have, you can see the list of scientist positions here that we are in the midst of searching for at various stages in the queue that we have there for HR. And we're actively seeking many of these positions, or will be actively seeking them soon. I'm really excited about bringing in a whole new set of scientists. Almost a third of our scientist ranks will be turned over here in the next, or added to here in the next few weeks and months. So really excited about that. In addition to bringing on new scientists, we need to bring on and replace some of our technicians that have retired over the years. And these have been great additions to our team and very capable individuals. And we want to not only connect with our scientists with technicians, but also obviously collaborators. At our sister universities around, our sister ARS stations, we really want to work to create an environment where we are able to continue and expand the multidisciplinary work that we've done here over the years. Additional focus will include things like understanding the interactions between the animal and the microbe. At a metabolic and genomic level, understanding these mechanisms of synergy between the microbes that are in the rumen and the gastrointestinal tract of these animals, as well as the host themselves. Also, I'm really excited about a new modeling effort that's going right now, looking at a very holistic dairy model. In the early days of our research center, the DAFOSIM dairy farming systems model really looked at some of the basic aspects of dairy production and modeling different outcomes, and really proved to be a very useful tool of trying to set out what's going to happen in the next generation and how do we get there from here. This RUFOS model is kind of the third evolution of that, if you will, which will include everything from crop production and manure management to animal management, nutrition, reproductive strategies, integrating cover crops and implications of that, grazing perhaps as well, economics. And so all of these things are going to be combined, and so that we can model multiple years worth of data through that model and see what's going to happen over the long run, and what are the chances of this, how this is going to work out over the long run rather than a point in time. So I'm really excited about the future of that aspect of our research. As I mentioned, cover crops. We're really going to dive in deeper in developing cover crop strategies across our country, and assessing risk for environment and public health risks associated with our industry, and making sure that we're doing everything we can to minimize and eliminate contaminants in our groundwater system. One of the chief objectives of the next few years is going to be to create and rebuild a research dairy. The existing research dairy, as I mentioned, is 40 years old, and it really is starting to show some of its age, and really has lost its ability to mimic what we want to see in the real world, or what we are seeing in the real world. We need to size it to the number of cows that we really need for our research trials. We need about 400 to 450 dairy cows to do our work, and so we're going to size that facility to that. Instead of the 300 and some, 320 was what it was originally sized for, and with dairy cows that were 1970s cows, not modern dairy cows. There's also a real need for an improved design for animal care and welfare, less risk to the environment. I really want to get away from the Wisconsin River. I don't want there to be any risk of contamination at all. I feel very good about where we stand right now, but also recognize that there are going to be environmental risks, greater environmental risk over time because of changes in our climate. We also want to have subunits that really model different segments of the dairy industry as we now know it. We will have things, for example, like freestyle setups, also comparing that, and having some subunits that are robotics modules, where we can conduct studies in all of those different platforms. We plan on doing some grazing work there too. Our heifer development program would be heavily influenced by grazing, and doing a lot more heifer grazing work, especially up in Marshfield. The new dairy at Prairie du Sac, the estimates are for it to be completed sometime late 2023 or early 2024. So we have a little bit of time before that will occur. But we are actively engaged in getting everything together that we want into the new facility, and very soon we'll be working with a design team, architectural and engineering firm to design our new research facility. So with that, I hope that gives you a little bit of an overview of what our center has contributed to the science of the dairy and forage industries over the past 40 years. And certainly we hope that the next 40 years are just as impactful and even more. We want to be very impactful and very relevant to the real world, and doing things that are going to make a real difference to the profitability and sustainability of our dairy farms and the dairy industry going forward. If you have questions, provide feedback, welcome that. You can drop me an email there at the address, or reach out to me by phone as well. Thank you very much for your time. Hope you have a great day.